What's up, guys? Let's start with the next derivation of straight lines. This is called as the normal form, also called as the perpendicular form. Okay. To start off with this, I'll give you an example where we learned vectors. Okay. Just stay with me for in this. Let's imagine this to be vector A. This is, if you feel this is irrelevant, then you're dumb. If you're able to understand this, the derivation of normal form becomes very simple. I know I'm trying to combine physics as well as math. So just imagine this to be A vector. Resolving the other day, I taught you. Let's say this is theta. Okay. You will try to resolve with two lines. Fine. So since the theta is touching this black line here, since theta is touching that black line, that will be called as the base. Wherever the word base is being used, we use cos theta. So this answer becomes A cos theta. Automatically, this becomes A sin theta. This is what you learned in physics. Based on this concept itself, I'll teach you how to derive normal form. Okay, so how do we draw? We do a regular diagram for a straight line. Okay, we make sure that one line touches both the things. Now, please focus from the origin whose coordinates are 0, 0. Everybody knows this. Coordinates are 0, 0. I will draw a straight line in such a way that it's going to touch this line. I'll make that black. Okay, so that's the perpendicular distance. Fine. Now, obviously, I forgot here is I forgot to mark this is to be 90 degree. Cool. Now listen, from this is where the actual concept starts off. This perpendicular distance is represented by the letter P, caps P. Fine. Now we assume that this angle is always anti-clockwise in nature, and this will be represented by the character alpha. Okay, which automatically means, think for a second. This line which I'm highlighting right now, I'll use a different color. I'll use some light color. The light colored line which I highlighted right now, since it is touching the angle, that will be called as the base. Wherever the word base is there, automatically, okay, one more thing, wait. So what I'll do, this yellow line is there, no? Let me not completely draw it. I'll draw another perpendicular like this here. Fine. I'll draw a box like this. This is, it makes our life much more simpler. That's why. Fine. So this also is 90 degrees. This also is 90 degrees. Fine. So we drew the perpendicular distance. You drop lines from there and simple. Now this specific theta. So since P is the vector here and theta is the angle, and this yellow line is being touched by theta, which means it becomes the base. Wherever the word base is there, all those places, cos comes into picture. So this becomes P cos alpha. If the yellow line is P cos alpha, the other line, which I'm drawing right now, will be P sin. Simple. Okay. This is the place where a lot of people trip over. You should not just remember it in terms of understanding the concept of resolving. Now, think for a second. If I give you a point 2, 3, how do you plot this on a graph? You will draw a graph. 2 on the x-axis, 3 on the y-axis. So 2 is here, let's say, and 3 is here. You will make sure they meet, no? And this point is called as 2, 3, which means this distance here was 2. This distance here was 3. Now think for a second. This distance here is P cos alpha. This distance here is P sin alpha. So don't you think this point's coordinate automatically becomes P cos alpha, comma, P sin alpha? Getting it? I'll repeat this. 2, 3 is a point. How do you mark it? 2 on the x-axis, 3 on the y-axis. You will extend lines wherever they meet. That's the name of the point. So the distance is 2 here. The distance was 3 here. Same concept. I know the distance right now. Distance was P cos alpha and P sin alpha. I'll take that. Automatically, I'll be able to name this point. P cos alpha as well as P sin alpha. That's it. This is the derivation part of it. Now what I'm going to do, automatically, I forgot one thing. Mark this. This will be point A. This will be point B and all things. Assume some random point. Okay. Assume some random point on this line AB. On line AB, assume some random point. I'll place it here and name it to be X, comma, Y. Reason is because I want one slope here. That's why. Fine. Now think, we all know that slope is nothing but something by something. Correct? No. When theta is given, obviously the y-axis by x-axis, basically slope means the y things come, y2 minus y when they tell, no, y-axis by the x-axis thing. So common sense here is slope for this specific point here. Okay. Slope will be given by, okay, multiple things will be there. Okay, I'll make it much more simpler now. Wait. So what I'm going to do, I assumed one point. I won't make it confusing here. This knowledge is not required. I will start with the derivation. Diagram part is almost done. Little patchwork is there. We'll do it when we're trying to derive it, when we're trying to write the derivation. So how do we start off? We write slope of line. Okay, wait 1 second. O, okay. I forgot to write one more thing, guys. This is O, and this is, let's say, L. Okay, so slope of OL is equal to minus of, okay, wait, we'll find this only. Slope of, what do you call, ML, we'll find. How do we know this? Slope is nothing but tan, no? So it's always, sine by cos. So here it will be P sine alpha divided by P cos alpha. Getting it? I just found the slope here. Fine. Y-axis by the x-axis. Y-axis is nothing but P sine alpha. X-axis is P cos alpha. P and P gets cancelled. Slope of OL, I got it as sine alpha by cos alpha. I can make it as tan alpha, but it's fine. Now think for a second. Using slope of OL, I'll be able to find slope of AB because OL, the line OL is perpendicular to line AB, correct? AB is that straight line here. OL is a perpendicular distance. We learned somewhere in 10th standard that slope of two perpendicular lines is nothing but m1 dot m2 is equal to -1, correct? So if m1, okay, m1 will be, or else m1 will be equal to minus of, m1 will be equal to minus of 1 by m2. Correct? Both of them are the same thing. This is what you learned in 10th standard. So based on slope of OL, I'll be able to find the slope of AB, which will be given by the formula minus of flip it, right? Minus flip it. So cos goes on top, sine comes at the bottom. So I wanted slope of AB. I use slope of OL to get this answer. Okay. Am I done with this? Not yet. Now this is my reference slope. Reference slope is found. Now, since I assumed one point, a random point on line AB, it's easy for me to find the slope. Just imagine this to be one point and the one which you found to be the second point. Obviously, it says y2 minus y1. So I'll take y minus p sine alpha. I'll take y minus p sine alpha whole thing divided by x minus p cos alpha. Correct? y2 minus y1 by x2 minus x1. P cos alpha. Simple. When 2 points are lying on the same line, it means both of them have the same slope. I know the slope of line AB. How? I found it using this method. Is equal to minus cos alpha by sin alpha. I'll equate it. That's all. I'll repeat this thing. So basically, you find slope of OL because you wanted to find the slope of AB. Okay, you got that perpendicular logic and you get this answer as a reference slope. Now you had assumed one point to be on the line itself. Based on this logic, you use m is equal to y2 minus y1 by x2 minus x1 logic. Y2 is y itself. Y1 is p sine alpha. You got this. Okay, this is y2. This is x2. This is x1 and this is y1. Y2 minus y1 and y minus p sine alpha by x minus p cos alpha. You got this. This is the slope of the line. Got it. But of these 2 points lying on the line AB. But the good thing here is we already know the slope of the line AB as a reference slope. We will equate it. Simple. Okay. Now once we equate it, all I'm supposed to do is regular math. Regular math meaning crisscross. Automatically, I'll use brackets right now to make it simpler. So it becomes sine alpha into y minus p sine alpha is equal to minus of cos alpha into x minus p cos alpha. So multiply sine alpha throughout. So it becomes y dot sine alpha minus p dot sine square alpha. Careful, sine into sine is equal to minus of x dot cos alpha. Minus into minus becomes plus p cos alpha. Now what? Bring all the squares to one side, cos square alpha. Squares, if I want to bring to one side, shift the without the squares to one more side. So y dot sine alpha remained as it is. The minus becomes a plus here. Plus x cos alpha is equal to p cos alpha was already there. The minus becomes a plus here. Becomes p sine square alpha. On the right hand side, I take p common. After taking p common, cos square alpha plus sine square alpha remains, which is nothing but the answer is 1 for this. So on the right hand side, the answer is p. Left hand side, rearrange it. It will be x comes first. That's why plus y sine alpha is equal to p. This is the meaning of normal form. That's all. So to repeat it, we will draw one straight line. We'll first draw the perpendicular distance. We'll drop two normals. Okay. Once we drop the normals, we assume one angle in the anti-clockwise direction to be alpha. So using resolving of vectors, I get the answer as p cos alpha and p sin alpha, which is nothing but the distance. Based on the distance, I get the point. Okay. Now, a slope of OL will be, OL and AB are perpendicular to each other. So I use the slope logic. I get this answer of slope of OL. Why am I trying to get the answer for slope of OL? So that I get the answer for slope of AB. Okay, so I use that, put a minus and flip the answer. So this will become my reference slope. Once I get my reference slope, I go back to the diagram. I assume one random point on the same line. The random point is nothing but x comma y. Now I use that regular formula for slope, which says m is equal to y2 minus y1 divided by x2 minus x1. I get my answer for this. I will equate both of them right now. Once you equate both of them, crisscross, do the regular math, bring all the squares to one side, bring all the non-squares to another side, get the answer, job done. 100% 5 marker this is. Okay, either this will come or the previous one will come, but I feel this only will come. Okay, practice this twice, please. I'll see you in the next class.